Concept 2, identifying direct variations from ordered pairs. Alright, so identifying a direct variation, it's pretty easy on a graph. Alright, you're looking for a linear equation, so a straight line, that goes through the origin. And if you see that, then you know it's direct variation. Alright, if you aren't looking at a graph, if you're looking at a table of values, you don't necessarily know if it's going to go through the origin. Okay, that point, that 0, 0, might not be in your table. So what you need to look at is the relationship between the values. And if we look at our equation, our graph here, we can find a couple points. So here's one at 1, 3. There's another one at 2, 6. Another one at, well, we can even go down here, -3, -9. And you'll notice a pattern starting to show up. And that pattern is that with a direct variation equation, every point, so every pair of coordinates, is going to have the same ratio. Okay? When I put it into basically my slope form, y over x, right? If you remember from your slope formula, that's the change in y over the change in x. But with direct variation, you don't even have to look at the change. All you have to look at is one of your y values with one of your x values for the same coordinate. Okay? So for here, I would have 3 over 1. Okay, this one would be 6 over 2, which is equal to 3 over 1. Right? And here I would have -9 over -3, which is again equal to 3 over 1. Any point on this line, and this line goes for forever, right? Goes to infinity. Any point on that line, if you take the ratio, it will simplify to 3 over 1. Alright, that's useful for us because it's an easy way and a sure way to find out if our equation is direct variation. Okay? The thing you have to be careful of is you have to check more than just 2 of the points. I might have 2 points that happen to both have the same the same ratio, all right, but my graph might be really weird looking, right? It might not be linear. It might be discrete. It might jump around. So in order to make sure, you need to check every single ordered pair that you're given. Okay, if you stop early, it might be that you got it incorrect. Okay, so let's check this one. All right. Okay, so I have my y over my x. So -18 over -3. And that is going to equal, let's see, what does -3 have to be multiplied by to get to -18? Well, I think that should be 6. If we divide this by 3 and that by 3, we'd come up with -6 over -1. We can get rid of the negatives because there's 2 negatives. So yeah, it'll be 6 over 1. Okay, another one. We don't have to worry about negatives this time. 12 over 2. Well, that one's pretty straightforward. Going to be 6 over 1. 5 over 20. Oops. And that's something you got to be careful of. All right, it's your y value over your x value. 20 over 5. Oh, well, no, because if I divide this by 5 and this by 5, I end up with 4 over 1. If I do this one, 36 over 9, which I don't really need to do, because if I've got one value that doesn't fit, it's not direct variation. If But if I check this one as well, yeah, this one's also 4 over 1. So it looks like this line would be coming up at a really steep angle, 6 over 1, and then it would lessen out a little bit and go at 4 over 1. So this is not a linear equation. Okay? It might still run through the origin, but we don't know because we're not given that point and it's not linear. All right? So there's a couple tricks or a couple things to look at that can help you with some of the tables. Okay? If you ever have a table that has a 0 value in it for one of the variables, and the other value on that coordinate is not also 0, it's not direct variation. Because this is telling me it's going to go through x is 0, y is 1. It's going to go through this point. Okay? So there's no way it can be linear and go through both of those points. So it's not going to be a direct variation. Okay? If you ever see that anywhere, there's a 0, but there's not a 0 for your other variable, it's not direct variation. Okay? One thing to be a little careful with is if you have both zeros, right? So this is telling me, yes, this line is going through the origin. Okay? That's a good sign that it's going to be a direct variation equation, but you still have to make sure that it is a linear equation, right? Because if we go back to our first one we looked at, you know, this one looked like it could be direct variation with these two, and these two by themselves, they looked like they could be direct variation, but our equation ended up having a bend in it, right? So it wasn't linear. Okay? When you have that origin as one of your points, you still have to make sure that it's linear. Okay? So to do that, check your change in your values. Okay? So I go up 1 for my x, up 1 for my x, up 1 for my x value. Here I go up 3, up 3, up 3. My change is consistent, so it's a linear equation. And because it has direct variation in it, I know that it's going to be because it has the origin as a point, I know it's going to be a direct variation equation.